Thank you so much for coming out to learn a bit about Canva and kind of get to know what we do and some of the career opportunities we have for you all. My name is Jess. I'm the University Program Specialist at Canva. I'm joined today by Scott on the end, who's our technical recruiter, and Jordan and Declan. They're going to be taking you through a bit more of like a tech talk and get into the nitty-gritty of the technology stuff that we have at Canva. So if you haven't heard of us before, we are an online graphic design company where you can design anything from this presentation to Instagram posts, your business cards, logos, divorce invitations, all the above. We've been around for 5 years now, and we've achieved a few milestones along there. At the moment, we have just over 15 million monthly active users. We're present in 190 countries, including 2 registrations in North Korea. And also, we're available in 108 languages, including right to left. Last year, we entered the largest internet market in the world, in China. So that included building an entire new entity, infrastructure, extremely localizing the product. And to get an idea of how frequently we are used, there are 30 designs created per second. For that, so yeah, we have 30 designs created per second. And about a month ago, we hit 1 billion designs created in Canva, so that's pretty cool. Something that's a bit more exciting, I find, than some really big numbers, is our users and their diverse background. So for example, there is an orphanage in South America that uses Canva to create their monthly newsletter. We have a sheriff in the States who uses Canva to create his wanted posters. And then a bit closer to home, there is a swimwear startup based out of Sydney who are now valued at $1 million, and they use Canva for every design aspect to help them grow to that number, which is really special. And then you've got people like Pinterest and Huffington Post, and about 85% of the Fortune 500 companies use Canva. So it was just 7 months after we launched to the public that we got our first marriage proposal. And since then we've gotten 15 more. So you know, it's not a bad love life for a SaaS company. But looking at the people, so who are these people building the product? What is their work life day to day? So we have currently just over 550 Canvanauts across 3 offices. So we're based in Sydney, Manila, and Beijing. And we're looking to almost double this number in the next 12 months. So if you asked a Canvanaut how would you describe their day, a lot of them would answer food. So we're lucky enough to have 3 on-site chefs alone in Sydney, and they cook us breakfast and lunch every day. And there are also endless amounts of snacks, Tim Tams, and it is in your onboarding that you'll probably gain 5 kilos when you start. Another way they'll probably describe their day is biscuit, not food. This is our office dog, but all the furry friends are welcome. It's really great when you live in an apartment and you can't actually have your own dog, because you can come to work and you take them for walks and you play with them, and then their owner has to clean up after them, so it's really good. But we do set some crazy big goals. So we plan by the seasons at Canva, so summer, autumn, winter, spring. And every 3 months we have an event called Season Opener. That's a time for us all to come together as a company, reflect and celebrate on things we've achieved, and set out the plans for the next 3 months. So to give you a bit of a better idea, I'm going to try and show you a video of one of our season openers from last year.
Today we're here because it's our autumn season opener. Our season opener is a really important part of how we do things here at Canva. So at the start of every season, what we do is get every single team together in the whole company. It's a really high energy, exciting day. each team basically gets up and does a pitch and sets their huge big goal that they're going to achieve over the next few months. So today we've heard from, I think, 48 different teams. You can see everyone in the background now behind me painting out their goals. It's a really awesome opportunity to bring everyone together, see what other people in the company are working towards, and really celebrating all of the wins that we've had.
There's so many great people to work with here. The office is amazing, and it's just like, it's a fun place to go to work every day.
My favourite thing at Canva is the way that you can really make an impact, and I find it incredibly exciting to be here every day. There's just so much energy.
The thing I love probably most about working for Canva is that there's so many smart people from different backgrounds working together towards a common goal.
What do I love about Canva? The thing I love most about Canva is that we're striving towards this crazy big vision, and I've been here for a few years now, and literally, because we're growing so fast, everyone's constantly stepping up, doing things that they've never done before. It's a really exciting opportunity.
So yeah, that's just a little insight into just a standard event at Canva, really. When it boils down to it, though, we want people to come to Canva and do the best work of their lives. So last year we had our first internship program, and we're bringing it back again this year, but bigger. So what that will entail is you'll come down to Sydney for 12 weeks over the summer period, and you're going to be working on projects that are launched to prod that our 15 million monthly active users can use. So you're doing work that makes real impact, which is really cool. Now, look, I can talk on and on and on about how Canva Office is really cool, but we want you to see it for yourself. So this was kind of a play on the golden ticket, but it's going to be Canva Coded ticket. So what we'll get you to do, I'll come up at the end and explain how you can win a trip to Sydney. So we bring 2 students down to Sydney to meet the founders, the engineers, and get a vibe for the office. But for now, I'm going to hand it over to Jonah and Declan.
Cool. All right. Hey everyone. So we are Declan, and I'm Jonah. So I went to UQ. I graduated in 2012, and I did mechatronic engineering and arts.
So I graduated in 2017, the year before last, in software engineering. So yeah, there were a bunch of slides before this, which is why this starts with one, but I deleted it because Jess explained half of it already. So I'm just going to go over basically what the product looks like, because a lot of you might have heard about Canva, but you don't know what we actually do. So we implement something called the editor in this screen, and it's basically a place you can design things, presentations, business cards, as Jess was talking about, but we also fill in the rest as well. So we offer like templates, pre-designed templates, so you can sort out the copy that you want. A lot of text groups, font combinations, color combinations, and palettes. We do stock imagery and photos, stuff like that, illustrations, graphics. We also allow you to publish directly to a lot of endpoints like Facebook, Twitter, as well as print. We support print now as of last year. So you can design your business cards and get 500 of them delivered to your doorstep if you want. And you've probably seen a lot of Canva designs actually in the wild and just not realized it. Pretty much anything that has text in it has been designed. That's a lot of typography around it. So like shopping malls, this is actually my local shopping mall in Sydney, and I noticed that they were using this Canva design. River Girls at UQ uses Canva for all of their social media posts. Maybe your local events like this QUT get together, like a network. Restaurant and cafe menus. This is like a local burger poster at one of the restaurants in Surrey Hills. Social media posts, Facebook, Instagram, Twitter, etc. And then this is like a photo that I took this morning at Mr. Bean's Coffee at UQ Union. And all of these are designed in Canva as well. So Canva could be anywhere. So we're going to go through 2 technical talks today. The first one will be focused on WebGL, and the second one will be focused on kind of like architecting a feature from scratch and what that looks like, and kind of like the behind the scenes You might see this simple thing that looks very innocuous in the UI, but there's a lot more that goes on in the backends.
Yeah, so if you've visited canva.com and you had a look at the sign-up page, you might have seen this sort of interactive animation thing. So we launched this last year, and I worked on some of the WebGL parts of it. So I'm going to go through sort of, see if, actually just to get an idea, how many people have worked with WebGL before? Probably. Okay, cool. So WebGL is kind of, it's similar to OpenGL if you've done OpenGL before. Probably no one's done OpenGL before either. So I'm going to go through kind of, try and give you a high-level overview of how it works, how graphics cards work essentially, how you send programs to graphics cards and run them to do something like this. Because an animation like this, we really need to make use of the graphics card to get good performance. So go over a quick overview of what is a WebGL program. So to start off with, it's essentially made up of two components. So you've got a vertex shader and a fragment shader. And each of those get compiled and linked together and you get a program essentially. So the difference here with a standard program that you run on your CPU is that your program on your CPU is actually instrumenting this compilation and linking process, which you then send off to the GPU, the graphics card. And these two shaders run in different situations. So a vertex shader runs for each vertex. So if you've got a triangle, then you've got 3 vertices. And it does some kind of transformation to those vertices. And a fragment shader runs for each output pixel, so every pixel on your display space. So if you're running full screen, then it's maybe 800 by 600 pixels, then it's 800 times 600 times that this fragment shader runs. And that's what lets you get this kind of, so the GPU can run all of those in parallel, and that's what lets you get this really great performance with WebGL over doing a CPU where you have to do everything kind of in sequence, except for the threading, of course. So in WebGL we have this, and OpenGL we have this screen space which is from -1 to 1. So the left-hand side of your screen is considered -1, and the right-hand side is considered 1. So if you imagine we have these 3 vertices, right? We're creating a triangle. We've got one in the top left, top right, and bottom left. And let's say our vertex shader, all it does is divide by 2, so multiply the x and the y coordinates each by 0.5. So you would imagine it would do this. So essentially, for each vertex, we run on the blue one, it sort of halves it. Green one halves it. So we've just created a scale operation with this vertex shader. So start off with a full-size triangle and we get a half-size triangle. The next thing the GPU does is it draws lines between them and it breaks it up into pixels. So once we've got all the pixels that it is going to be outputting for that triangle on the screen, we can now run each of those pixels in parallel and we can run the fragment shader for each of those pixels. So let's say we've sent some information along with those vertices. So we've sent red, we've sent blue, and we've sent green with each of those vertices. So let's say our fragment shader, what it's going to do is just take the color that was sent with that vertex and draw it. So for those pixels, easy, it's just that color. But for the other pixels, what the GPU does is actually interpolate the values that you give it, and you end up with this kind of gradient. And fill it in with all the other pixels and you get this triangle. If you've ever seen like an OpenGL tutorial and you've seen like how to draw a triangle and it takes you like a week to figure that out, it's because like that's most of WebGL. Once you've got to that point, you understand vertex shaders and fragment shaders and compiling WebGL programs. So don't get discouraged if it takes ages to just write a triangle. So talk a bit now about how our blobs work on that homepage interactive animation. We actually have 3 programs, and each of them produce some output, which some of them we store in a texture, and then we use that as an input for another program. So the first program we built is this fall-off sprite, which essentially draws this kind of circle where in the center we draw, so if we're drawing a center pixel, we draw 100% opacity white color, And if we're drawing the edge, then we draw a 0% opacity color. So we get this kind of gradual fall off. So it's just kind of like a circle. And then we take the output of that program, we store it in a texture on the GPU in memory. And now for each of those blobs that you see on the screen, we draw a square. So essentially 2 triangles gives us a quad, a rectangle. And we copy that texture to those vertices. So all the second program does is basically copy pixels across the texture. We do that a bunch of times, once for each of the blobs. And once we've done that, we can actually, so you'll see that the sort of opacity adds up. So if you've got a 30% opacity pixel from one blob and a 30% opacity pixel from another blob, they'll add up to give you a 60% opacity. And then we can actually store that output as well into another texture. And then we take, in the bottom left there, you'll see we've got the image, which is the sort of mask image that you end up seeing. And our third program, which composites the two, can read the pixels from both of those textures on the left. So we can check a pixel and we can say, okay, what's the opacity of that pixel? If it's above a certain threshold, then we'll draw the pixel from the image on the bottom left. If it's not, then we'll draw transparent. So we do the same thing, we draw the vertices that fill the whole screen, and then instead of drawing every pixel from the source texture, we draw only the ones that cross over that threshold. And that's basically it. So that's kind of a high-level overview of how this works. And you see, as you get kind of the edges of blobs, they kind of have this sort of effect where they kind of look like they're joining together, but they're actually just, it's just crossing over that opacity threshold, which shows the color. So that's the WebGL bit. Now I think Declan's going to talk about yeah. Actually, before we go on, does anyone have any questions about that? Yep.
I guess like the logic, the physics and everything wasn't done with WebGL. Are you guys going to cover that?
Yeah, so the physics and everything's still done in the CPU. We could do it in the GPU. It's a bit harder. We probably didn't need to, like the amount of effort that we've got, because it is harder to sort of build programs for WebGL. There's an extra layer of indirection you have to worry about. So if you can do it on the CPU, then, and the amount of physics we do is fairly minimal, because we've only got like maybe 20 blobs. So we just do that on the CPU.
Yeah, so the shaded programs that you just mentioned, are they done on the server side or the client side?
It's all client side,
Okay.
yeah. So essentially they're just a string that comes in the bundle, the web bundle to the browser. The browser just sends that string off via a WebGL function, and the browser knows how to handle that text and combine it into the program. Cool.
Okay. Okay, so this second talk is going to be talking about kind of like system architecture. So what we saw there with the blobs was very much a purely client-side feature. And this one's going to interact with the backend, it's going to interact with different parts of the cloud, and we're going to see how it comes together. So first off, like imagine if you got these mock-ups. So this is a little help button in the bottom right of the editor. Actually, I can show you. And it says need a hand, and you click it, and then it's got a couple cards. You can click into these cards, and then you get like this info card that has a lot more information. To Canva, to start designing, choose a template, blah, blah, blah. And these link off to other cards as well that give you some more information. And then there's like this little, what's this helpful? I'm currently set to the Aussie locale, that's why everything's like this. And this is show your mates. Please ignore that. So this little help tool. Quick show of hands. So this little help tool, which is basically Clippy, how many people think that it's going to be easier than the blobs animation that we just saw. Around the same difficulty. And how much harder do you think it'll be? Like maybe 2 weeks of work? 4 weeks of work? 3 months longer? 6 months more work? A year? Alright. We'll do the presentation first and then we'll see afterwards. So in this presentation, I'm just going to go over basically kind of what components fit into the system, what are the different subsystems or subservices that it touches, and that sort of thing. So first off, from the crowd, what systems do you think you would need, or what features do you think you would need to implement in order to get this little clippy tool done? So just to start ball rolling, obviously we're going to need a UI, so we're going to need to have a little front-end code to handle these cards, render them, click through some history state, somewhere to store all of our card data, whether that's server-side or client-side, some way to search all of our cards. I think I didn't show it there, but there's a little search bar at the top. And some way to deploy new cards to our users. So if you have any ideas of what else you might need, just raise your hand and shout out. Otherwise, I'll continue. Yes?
Testing?
Yes, a big one, massive one. The one that doubles the time of development. Neil? Okay, I'll continue on and we'll see. So, again, this was the component. We've got cards, we've got a search at the top. Otherwise, it looks like that. So in the UI alone, we have a couple things. Obviously, we have card navigation and history states. So there's a little back button at the top. You can go back to the previous cards that you visited. We also have placeholder states. So when your content is loading, it doesn't suddenly flash in. Everything is nicely animated. There's error handling, which we hopefully will never see. We've got animations. So again, nothing transitions suddenly. We've got fades and smooth transitions between everything. Cards have actions and buttons and links, and some of them do certain things. And then in the back ends, we have a persistence layer, so some sort of database or file that holds all of our card data. We need some way to ingest all of that data. And then we also have to have a rich text editor. So we have to have a completely different front end for our content writers to access this data, manage it, update it, create new cards, keyword them, because it's not going to be a developer's daily job to write new cards and add them to the code. And then the big one is localization. So all of these cards need to be available in all of our languages that we support, so 130 locales currently. And that basically doubles all of the work that we have to do already. So card navigation and history, how does localization affect that? It's not just a language thing. Some locales have right to left, so you have to swap the entire UI completely. A back button needs to be on the right-hand side and it needs to transition right instead of left. All of your UI has to be audited and checked that nothing overflows in languages with words that are a lot longer, like German. And all the content needs to be translated, obviously. That's a big one. And these translations need to be dynamic. So whenever we update a card, we obviously have to update all the translations that go with it. We also occasionally update our terminology. Some of the cards have information about our product features that change, and that has to be all updated. And search. So search is a massive one. Cards are added all the time, and whenever you add a card, it has to be added to the search index. And search needs to work in all of the languages as well. So that's 130 times. And search has to work with both keywords as well as full text search inside all of those cards. So if someone searches for, I don't know, Canva for work, it has to search inside every card that says Canva for work. And then there's way more on top of this. Cards need to be able to link to each other. All of these data pipelines need to be connected together. All of our assets need to be pulled out and put to a place that it can be accessed easily. And then there's all of this infrastructure about setting up instances and pipelines and stuff like that, which I'll go into detail afterwards. Because we have a search service, basically, and that's completely on the server side. So we basically have a Java program that spins up, and it's got a search index in it. That needs to have load balancing at the scale that we are at, and it needs to have security groups and permission models and all that kind of stuff that comes with a big organization. And yeah, so we need error monitoring around this new instance, this new Java program, so that when it flares up with errors, we can check it, we can restart it. It needs tests everywhere, as you mentioned. Design docs, user testing. We need analytics and metrics around what cards people are accessing, what search terms that they're searching for, so we can populate the Help Center with more useful articles, and so much more. So I'll just dive right into it. For creating our cards and writing our content, we use a service or another program called Prismic. And this is what we call a CMS, or a content management system. So a popular content management system is WordPress, so it lets you kind of edit content and then publish it to a website. Prismic is what we call a headless CMS. So it only deals with the editing of the data and management of the data, but it doesn't deal with deploying it or viewing it or showing like public users that data. Instead, it gives us an API, and we can basically request all of our data through it, and then we can basically render it in a custom fashion how we like. So for this card on the right here, you can see the data that represents it on the left. So we've got like an ordered list here, and then one of the items says open the folders tab in the editor side panel, and then folders here is bolded, and that's that first step here in this list of instructions. And this is what Prismic inside the editing tool looks like. So our content writers will have access to this tool. They come in, make new cards, and then there's this rich text field here that lets you type some text and fold things and insert images and stuff. And then we pull it down, process it, and render it to the card like that. And then of course the other UI stuff. So as I talked about, this loading placeholders, which you can see here. So when this list is loading, it's got those flashing animations. Same with when this image is loading. And that's basically so the image doesn't just pop in suddenly and then reflow all the content. You get some contextual information about what's loading and what to expect. And same with like this card resizing, right? When you navigate to a new card, the dialog basically resizes naturally and it scales up. Unfortunately, I couldn't get a very good visualization for this because it's all just pipeline code. But I'll try to explain it as best as I can. So on the top left there, we have Prismic, that CMS that I was talking about. And in order to get it to our users, we have to transform it in a couple ways. So as I was talking about before, that search and that localization, so we need to translate all of our content and then somehow build a search index around it. So this diagram covers that. Every day, we pull down all of the new content from Prismic. And that's basically a really, really, really long blob of JSON, if you're familiar with it, but it's just a data format. For the English messages in it, we extract that all out and we store it in a cloud file system called S3. And then for the translation side of things, we get those extracted English strings and we push it to a service called SmartLink. And SmartLink is basically translation as a service. You push English strings into it, and then a couple days later, once the translators have gone through it, you pull down any translated strings. So that's what this second job here does. So build kite job number 1 and build kite job number 2. Build kite is the name of our continuous integration system. If you have done Deco 2800, which I highly recommend, you will have used Jenkins or I'm not sure what you guys use now.
Used to use Jenkins in 2020 as of last year.
Yep. Basically, it's just a server in the cloud that runs jobs from now and then. So the second job here, which also runs daily, that will fetch any newly translated content from Smartly, so stuff that was probably put in a couple days earlier. It will try to remap it to the original content that it came from and merge it so that way we get the right card and the right content coming together. And then it pushes that as well to our cloud directory in S3. And then finally, we have this Java program running in cloud called Help Service, and that basically pulls the stuff down from S3, also daily, and runs a search index called Lucene, which is provided by Solar, but Apache is the name of the company that runs it, develops it. And it's just an in-memory search index. We build it around that JSON, and it basically, with a bit of configuration, it lets us just query pretty much everything inside this directory. So whenever you make a search query inside the assistant or click a card or whatever, it's going to go and try and fetch that card from Help Service, looks it up in the search index, and then retrieves the card and returns it back to the front end. So Smartly, we'll go into more detail now, but it looks like this. And so you can see here on the left, we've got a bunch of English strings, and then on the right, we have a bunch of already translated Japanese text. And right now, this is in the web project, so this has like every string, it's like 44,000. And this is what the Smartly editor looks like. And what's really cool is that, so we've got on the left here the original English source strings, and then on the right, the Japanese text, and I'm currently editing this one. And then up here, you can see the contextual information about where this content came from. So it's highlighted here, this third step in this card. And you can see here the fourth step is untranslated right now. It still says click apply in English when it should be in Japanese. So this is what our translation vendors will see when they are translating Canva. So from content writer to user, this is the entire flow now. It's basically the same as the previous diagram, except now we've got Help Service and these arrows that actually tell you what's happening. So the assistant will try to make a search query and query cards and stuff like that, and Help Service will just respond with everything that's in the index, which means that any card that's added in the last day or so won't be in there yet. And then on the assets side, this is just an extra flow that wasn't in the previous diagram. Any sort of like images that are inside Prismic, we need to host it in a location that's accessible to our users. So right now we are pushing it to S3 as well, so another cloud directory, which basically makes it readily accessible to pretty much everyone that we support, including China, which is great. And that's basically it. And yeah, Jonah can give you an estimate on how long it took to get the MVP version up.
Yeah, I think in the end it took us maybe 6 months, 9 months to get the MVP. There was 2 of us working on it. And now we have a team of 3 people that pretty much maintain it full time. So they're working on adding new features and sort of fixing bugs and working with the content teams.
So basically, for your personal projects, you're going to need not much of this. You're not going to need to translate it into other languages or anything like that. And because you don't need to translate it, means that you only have one bundle of messages, so you can probably just hard code that into your front end. You probably don't have your own personal content writer, so you can just do it in the code. And so all of this is probably just I'm trying to illustrate that for a production scaled version of a feature, it normally adds a lot more complexity behind the scenes to what you just see in the UI. If you were doing this in your personal projects, it would probably take 2 weeks. Yeah. So that's pretty much it.